So, do you want me looking at the camera? Before I design something in Fusion 360, if I try to create models of everything that it's going to be in the real world that I know the sizes for and stuff. So in this case, the knife blade itself is the real world object that I'm wanting to hold. So that was the first step in creating my knife holder, was creating a model of the blade. I 3D print it, and so I create my first version of drag knife. This is a typical 3D printing procedure. You fine tune it. That's the beauty of 3D printing, in fact, is that you can iterate your model until it's, you get what you want. And in this case, I had to go through some iterations. So I designed the first knife, and I took it to the Shopbot and ran it and found its deficiencies and came back and made a better version until I ended up with this. In my head, even though I didn't formally write them down, there's a certain set of expectations or specifications for what I want the design to do. So in this case, I know the blade's going to be in an angle, that I'm going to have a pivot point, the blade needs to go a certain distance into the material thickness, and then still have enough blade that's out of the material so that my pivot point is out in front of where the blade's cutting at. So those are all kind of specifications on the design, and from that I created the original design. So the first iteration was going to drag the tip of the knife blade along the surface and get it lined up by just dragging the tip of the blade, because I couldn't depend on it getting lined up with it fully engaged with the surface, because if it were at 90 degrees to the direction of travel, or something close to that, it's not going to make the turn. But if we were just traveling on the tip, I should be able to turn it in the right direction. The surface of the coroplast is not perfectly flat, and so dragging the tip along the surface was not doable. I couldn't control it well enough to actually just touch the surface. So that's when I came up with the foot. So the foot is actually on the same line as the blade. So it's in a position where, as I turn the knife around, the blade is in the direction that I'm traveling in. The foot is behind where the blade's going to contact the surface. So I can use the foot in two ways. The main concept is the foot becomes that surface that's behind the pivot point along the line of the blade, that as I'm dragging it on the surface, it wants to rotate the knife into the direction of travel. And the foot does that great, because I can push it against the surface of the coroplast with enough pressure that it will rotate the knife into position, but it's able to drag. It's able to slide along the surface and not grab like the tip of the knife blade was. And then I added to the algorithm the ability to pivot around the foot itself, so that I don't actually have to drag it initially. If I know which direction the blade is in now and I want to point it in another direction, I can pivot on the foot and much more efficiently get it lined up in the right direction, and I don't have to depend on the dragging action. So I added that to my algorithm for the toolpath. Ultimately, I've created a toolpath, a drag knife toolpath, for the toolpath that the plotter would do for a drag knife. Now, parts of it are general for any drag knife, and some of it are for my drag knife with my foot on it. Getting it lined up for the next cut is unique to this drag knife with this foot. And that's built into the algorithm that generates the toolpath for a Shopbot. Part of the algorithm that I ultimately came up with was, when the knife lifts out of the material and the foot's clear, it should stay in that position. So as I'm moving from one position to another to do the next cut, I know which direction the knife was facing when I finished the last cut, and so I depend that it's going to stay in that position because there's really no reason for it to turn. You know, vibration or something might, but typically. So now when I get to the next position and I come down into position, I can rotate the knife to line up for the next cut. So I rotate it, line it up for the next cut. Now I'm not, by building that into the algorithm, the foot doesn't have to drag across the surface so much. Here's a collet. One of the things I came up with that I realized, I'm changing the tool out on the Shopbot the first time I start using it, and I have one collet. I keep changing the collet, pulling the collet out, putting the next part in and all that stuff. And it occurred to me that, you can buy these collets on the web for just $12. It's worth it. What happened was when I started with the first drag knife where I was putting it right into the router, and I'm depending on the router's bearings and such to, let the thing pivot around, I'm finding that the router had enough resistance that when I go to pivot the knife, I'm having to push down with the foot pretty hard to get enough friction to definitely move the knife around. And I wanted it to have a little freer, so I ended up getting a 1/2-inch collet with 1/2-inch bearings, and I got a 1/4-inch thread here from a 1/4-inch bolt that threads into the nut. So this is my final design for the drag knife, and it pivots freely. You have to clamp the edges of the coroplast to hold it in position, and I don't want to be cutting into a clamp. So my thinking was, as I draw everywhere I'm going to cut first with a Sharpie, and so this Sharpie, I have this nub on the top of it, which is just some electrical tape. But the idea is that as it goes into the collet, that nub holds it in position at the depth I want, and we'll put the cover on it. Now in this case, unlike in fact, both the examples I gave of offsets, this doesn't need an offset. When I'm generating the tool path, if you will, for the pin, I'm moving the router exactly on the line that I want the pin to move on, so I don't have to do any offsets, whether tangential or normal. The code for all this is, out there on the web, on GitHub, and you can go look at, you'll see a table that has characters for the font that I draw the labels with. In the next episode, we cut panels on the Shopbot.